Hello everyone, welcome back to my channel Mana Concept Lab Pro. Before we jump into today's video, make sure you smash the like button, share this video and subscribe to the channel right now. And don't forget to hit the bell icon so you never miss any awesome updates from us. Your support means everything and keeps us going strong. Alright, enough talking, let's dive straight into today's exciting video. In today's video, we are going to talk about characteristics of object-oriented programming. So in object-oriented programming, we don't just write code as list of steps like we usually do in procedural programming. Instead, we use objects and then classes to organize our code in a better way. This actually helps us relate programming to the real life situations. Now you might be thinking, why do we even need this programming language like object oriented programming language? Well, in procedural programming, everything is written in step by step. It works fine for small programs, but as the program gets bigger and bigger, it can become messy and hard to manage. That's why object oriented programming helps us to break this big program into smaller, reusable parts using objects and classes. This makes the code easier to understand. We can reuse it and also we can maintain it. That's one of the main reasons why object oriented programming is so widely used today. So in this video, let's understand the key characteristics of object oriented programming in a simple way. And also, but before we get into that, let's quickly understand two important concepts in this, which is objects and classes. You really need to know what is an object and what is a class. A class is like a blueprint or a template here. Now let me give you a simple example so you can clearly understand what a class actually is. Imagine a blueprint of a house. It shows how many rooms, doors, and windows are there, but it is not an actual house. In the same way, a class defines what an object should have. It defines the structure and the behavior, means the data, what it should contain. And it also acts as a logical structure, not a real entity. Structure means what things an object has. What is behavior? What an object can do. Structure in the sense the data or properties of an object. For example, name, age, color, marks. These are stored using variables. And behavior. Behavior means the action or function an object can perform. These are defined using methods. Also, a class does not have memory for data. Memory is allocated only when we create an object from that class. And a class typically contains variables to store the data and methods to define the behavior and constructors to initialize objects and more features depending on the language. So in simple words, a class is equals to structure means data plus behavior. Function, what functioning of that. Now let's understand objects in a very simple way. An object is an instance of a class. What it means? It is a real world entity. It is a real world thing created from a class. Example continuing, if a class is a house blueprint, then objects are the actual houses built using that blueprint. All houses follow the same design, but they can still be different, like having different colors, having different owners, different locations. In the same way, objects created from a class can have different values, but they follow the same structure. And also, objects are used to access the data and the methods defined in a class. Also, every object has its own separate data. They don't share memory with each other. Now, every object has three main characteristics. One is state, represents the data, the values stored in the variables. If name is equals to Bhavishya, Bhavishya is a value which is stored in the name variable. And the next one is behavior. Behavior represents actions. These are the methods or the functions the object can perform. And the third one is identity, represents uniqueness. Each object is unique. Even if two objects have the same data, they are still different because each object has its own separate memory location. That's how objects work in a simple and clear way. Here object is equals to state plus behavior and then identity. Alright guys, now let's dive into a super important concept in Java, memory management. This might sound confusing at first, but trust me, I'll make it super simple for you. First thing, objects are stored in heap memory. Think of heap memory as a big storage area or a warehouse. Objects can be large and complex, like many variables and methods will be present, and the size is definitely not fixed, and they need to live longer even after a method finishes. So objects are stored in heap. And in this example, student s1 is equals to new student. The actual object student is created in heap memory because Java does not know the exact size at the compile time, so it uses dynamic memory allocation. That is why heap is perfect for dynamic allocation, large or complex objects, or long lifetime. And the next one is references to objects are stored in stack memory. And here coming to stack, think of stack memory is like a desk. References are stored in stack because they are small, just memory addresses will be there. They need fast access. They are related to method execution. And coming to the same student example here, S1 is a reference which is stored in stack memory. It only stores the address of the object in heap. That is why stack is perfect for temporary variables, fast execution and method calls. Now you might able to understand what is heap memory, why objects are stored in heap memory, what is stack memory, and why references to objects are stored in stack memory. Now let's clearly understand instant members and static members. It is one of the most important concept in Java. In instant members, memory allocated during object creation. To easily explain here, instant members are the variables and methods that belong to an object. Memory is allocated when the object is created. That means each object have its own separate copy. If we created two objects here s1 and s2, then s1 dot name and s2 dot name has its own memory. S1 dot name has its own memory and s2 dot name has its own memory. Even though both created from the same class, they store different data in different memory locations. Here important point is objects are created in heap memory and each object carries its own instance variables. And coming to static members, now let's explain about static members. Static members belongs to the class, not to objects. In static members, memory allocated when class is loaded. It means memory is allocated when the class is loaded. It belongs to the class, not to the objects. This happens before any object is created. Only one copy exists, all objects share the same data. Means here inside class a memory is allocated. It means only this will share to the all objects. If we have a static variable like name equals to hello, s1 dot name and s2 dot name here both point to the same memory. So if one object changes, it reflects for all objects. This is the simple difference between instant members and static members. I hope you all got it.